Hello Year 11 Mathematics Advanced students. Today we're continuing on with the topic of Introduction to Calculus and we're learning about differentiability. So the process of finding the gradient function y equals f dash x for the function of y equals fx is called differentiation. This process is done algebraically. Y equals f dash x is called the derivative function or just the derivative. The process of differentiation can only be done on smooth and continuous curves. A smooth function has no sharp corners. A function is not differentiable where it's not smooth. This function over here is not differentiable at x equals c, since it is not smooth at that point. So at x equals c, it is not smooth as we have this sharp point occurring here. We cannot draw a unique tangent there, so we cannot find the gradient of the function at that point. So a continuous function has no gaps or breaks. A function is not differentiable at any point where it is discontinuous. So this hyperbola is not differentiable at x equals a because the curve is discontinuous at this point. So if we look at x equals a, the curve is discontinuous, so it doesn't occur there. And over here, the function is not differentiable at x equals b because the curve is discontinuous at this point. So here we have an open circle, and that means that it doesn't occur at that point. So that means it's discontinuous at that point. So for differentiability at a point, a function is differentiable at the point x equals a if it's continuous and smooth at x equals a. Moving on, let's have a look at some examples. So we want to find all the points where the function below is not differentiable. So we have a graph here and we have a couple of points. So remember, for a graph or a function to be differentiable, it needs to be smooth. So the function is not differentiable at points A and B because the curve is not smooth. Because the curve is not smooth at these points. Also, it is not differentiable at point C because the function is discontinuous. At this point. At this point. So at point C, we see that it's discontinuous due to the open circle, and at points B and A, it's not smooth. Okay, moving on. So is this function fx equals x squared for x is greater than or equal to 1 and 3x minus 2 for x is less than 1 differentiable at all points? So this is called a piecewise function, and we want to sketch this piecewise function as it will show where it's smooth and where it's not differentiable or where it doesn't occur. So our first point of our function is x squared for x is greater than 1. So if we were to graph x squared, if we were to just draw up a quick table of values over to the side, and so we only want our, I've done that again, our x values greater than 1. So we'd have x, y, 1, 2, 3, 4. Yeah, that's all that we'll worry about. So at 1 squared is 1, 2 squared is 4. So that means at 1, we're just going to go up into a parabola. So at this point, 1, 1, we're going to go up into a parabola. Then for the, so that was for y equals x squared. That's 9, that's 16. And then for our function of y equals 3x minus 2, we have at 1, we'll work out what's going on. Well, we have that actually we don't even need a table of values, because what we should know that from a standard equation of y equals mx plus c, our m equals 3 and our c equals -2, where our c is our y-intercept. So that means we're going to have, for this part of our graph, we're going to have a y-intercept of -2, and then our gradient is 3. So if we go up 1, 2, 3, and across, we get it there. So that means we're going to just have a straight line going through this point. So like so, except I might do it with my straight line thingy on. Nope. Okay, I'm not going to do that. So you guys would use a ruler like so, and that wants to be a straight line. Make sure you use a ruler. So this is y equals 3x minus 2, and this is y equals x squared. So that's our piecewise function. So now we want to say that by sketching this piecewise function shows that it is not smooth where the two parts meet. So it is not, oh, that's a weird O, not differentiable at x equals 1. So at x equals 1 point there.